కొంచెం వాల్యూమ్ తగ్గించు. Yeah, which question? Is this? Okay. Yeah, tell me. Okay. Okay, yes. Okay. Uh, so no gauge is designed for maximum material limit, right? Sorry, minimum material limit. So any comments from the students? Okay. I think I have discussed something in the last class. So have you checked the answer given, the key given in the set? Okay, B is not there. Okay, I will just check what's the key given and what's maybe option C is the key given. I will see any discussion is there in that paper. I will give an update in the next class. Let us go forward with the two-way session. Yeah. Okay. So, mm, so, apart from this question, is there any doubt in other questions? Any of the students? Are any doubts in the concept? Okay. So till now we discussed the basics of metrology, then fits, tolerances, and these limit gauges we have discussed, and I think a little part of linear measurements. So in this class we'll continue with that. We'll try to complete this angular measurements, then a little bit of interferometry, and if time permits, I will also try to complete this surface measurements. Or else I will discuss that in the next class. So, so this is the reference, a nice reference to follow for this engineering metrology. So this is fifth class of metrology. Sorry, fourth class of the metrology. So let us start with these slip gauges. Uh, so, anyone know about slip gauges? Can you give me what is the purpose of using these slip gauges? Anyone?
For measuring distance between two surfaces.
Okay.
Sir, no dimension blocks which we can use like a comparator.
Okay. Anything on the preparation of these slip gauges? What material we use? How the surface finish will be for this?
It has smooth surface finish.
Okay. So if you remember that 8000 or 01, so that's the tolerance we use for these slip gauges. Any what material we use for slip gauges? Okay, mild steel. Why mild steel? So generally we have to use like very hard surface finish. So we can go with this HS high speed steel, or you can even go to this heat treated surface. Okay. What are the preparation of this process? Something related to this smooth finishing only. So basically, we take the steel blocks, then we cut into according to the sizes, then we grind it as smooth as possible. Then final finishing will be with the lapping process. So where we use a workpiece, and then with standard plate, we use some ceramic powders, and then we suppose like alumina of some 50 microns or even less. Then we try to polish by hand or using any polishing machine. So this surface finish will be very high, such that these are sort of magnetic. So have you seen physically these slip gauges?
Yes, sir.
Okay.
Yes.
So do you remember the set name?
It did. Yeah, 42.
42 or 45?
46.
Yeah. So it's like intuitive. So there will be total 45 different slip gauges. So these are like we have to use, like there are some principles. So we have to use a limited number of slip gauges for the measurements. So regarding that, so in 45 sets, we will start with some 1.001 to 1.009. So that will be so total 9 sets. Like that we will go till these are in mm. So the sets total will be 45. Similar with this M88, but with different size of the slip gauges. Okay. Then this what I am mentioning is the height of the slip gauges. The face length will be like 15 to 10 or even less. Okay. This whatever I am mentioning 1.0, these are the heights of the slip gauges. So I will keep them as a stack so that I will get the desired height. Okay. So just let us do one small like numerical, then we proceed with the next concept. So I will. So these are the things you have to keep in mind. Just suppose if I want 10.39 mm height, so what would be the combination of sets? I will give one more one. So what will be the, so for getting these values, so there are so many combinations I can use right now. So what would be the best combination?
Plus 1.3 plus 1.09.
Good. Yeah, nice. So any other combinations?
Sir, how do we identify the standard sizes?
Yeah, I will discuss in a minute.
By selecting the minimum number of slip gauges.
Yeah, that is true. But how? There is a simple method we divide.
Start from 10th digit.
Yeah, correct. So basically we will start with this digit. So that is 1.09. Then let's come to the, we will see in the standard set, then we will come to the next place, 1.3, then we come to the final one, if we have this size. Otherwise we will split that also. So total in 3 slip gauges I am getting this value. So this is how we decide the standard sizes. Yeah, sorry, there is a small disconnection. So did you get the thing? So we have to get the last digits, 10th or 100, then we will come next, so that we will get the standard sizes. Here we are using only 3. That's the best possible combinations. So you can get in a question, you have just remember these sets. Then if there is any question, I don't think they will give this much question, but if there is any question, they might ask how many slip gauges you should use. All the options given will be correct, but you have to choose the minimum number of slip gauges. You have to do this process and then you can calculate easily. So I will give one more example, you can try. So 35.624. So how many slip gauges I should use for a normal set, that is M45, and for a special set that is M88. That is I think M87 or 88, whatever. So how many slip gauges I should use for this to get this size 35.64.
Five.
5.
Yes, sir.
Okay, nice. Special set. Okay. So as I discussed, we'll start with this. That is 1.004.
सर इसमें सर M88 M112 होता है
M88.
सर स्पेशल साइड M88 और M112
M88.
ओके सर
Okay. Then we'll come to the next one. That is 1.02. Then 1.6. Then this 35 is there. But if you can calculate this, how much you are getting these three values?
3.625.
So we go for 30 and 2, if I'm not wrong. Then 30 plus 2. Okay, you're getting right. This is for M65 set, 45 set, sorry. Similarly for M88,
Sir, what is the range and steps of M88 set?
okay, this special set or normal one?
Sir, special set.
Okay, yeah, I will discuss. So in special set we'll have more divisions, so it is easy to calculate these values. So within 4 you will get the thing. So I will quickly give this these things. You just note it down. No need to remember. So you just have to maximum you can remember normal set. If you can see, if you can observe how the divisions are happening, it is easy to remember. So as I discussed, in normal set will total have 45. So this step indicates the increment in the values. So 1.0012, 1.009. So the increment is 1.001. Total 9 we have. Then 1.012, 1.09. The increment is this 9. Then 1.1 to 1.9 is 0.1. These are also 9. Then 1 to 9. Then the other one, so here initially we start with this. Increment is total 9. Then here we'll have 1.01 to 1.49. with an increment of 0.01, and these are total 49. Okay, then again we have 0.5 to 9.5, so we'll have a step size of 0.5. These are 19, so 10 to 90, these are 9. How much is this? 9 plus 49 plus 19 plus 9.
86। नहीं नहीं, ये तो बहुत कम है सर।
What?
86.
86.
But the set is 88. So we'll have a 86, then we will have 100, and then we'll have 1.00. One more set will have 1.005. So plus 2. Total 88 we have. Okay, these are like the additional one we have along with the range.
Sir, since we already have 1.005, so why there is repetition?
Yeah. I think this is something related to minimize the set these slip gauges with the combination. Suppose if you have a combination of 1.005 as well as 1.005, so in that cases it is easier. These are like empirical practice.
1 point, सर उससे बेटर तो 1.01 है, दो हो जाएंगे ना वो तो।
Yeah, that is true. Something related to empirical, like in experience they found it. Okay.
Okay.
So this you can quickly remember. Then we'll go. So this is the like main thing comes to your mind when you see any angular measurement. You might also have a this thing in your lab. So this sign bar. So let us quickly discuss these properties. So as you can see, these are different names we give. So they basically it will have it has a flat surface, then with two rollers which are fixed rollers with an Allen screws. Then we'll have a basically it's in a hollow to reduce its weight, and it is made of the same material that I discussed earlier. So these are with this we can measure. So these sign bars are like so if I want to identify any sign bar, we'll identify by the length. So this L value, say 100 mm sign bar, 200 mm sign bar. So this length between these rollers is fixed, and the roller diameter also fixed. So these are the very nicely prepared samples with very little tolerance, I can say. So these we can use for measuring this this theta that is being showed here. So these are like the not the direct measurements types. These are the direct contact but indirect measurements. So this will not give direct measurement of theta. So we have to use this formula. Okay, sin theta is equal to height of the slip gauges divided by the length of the sign bar. So this length will be always be the hypotenuse, and this slip gauges heights will be slip gauges are any height, any surface height which is having this non-uniform height. So that will be the opposite side for this formula. So sin theta is equal to h by l. So and then these will be a limiting value for this theta. So the best possible is 45 degrees. Till 45 degrees we can use the sine bar without any obstructions, but above 45 degrees actually the error in these measurements will be, this indirect measurements will like shoot up. So that's why we will not go beyond 45 degrees for this measurement. If you are interested by this 45, how this 45 value is coming, you can just derivate this sine theta with respect to theta as well as the other parameters which are variables, and you can finally derive one nice equation which end up like, so d theta, that is the error in value, will be tan theta into dh by l, I think dl by l, I think. So this is the final equation you will be ending with. So this tan theta value till 45 it's okay, but beyond that this will shoot up like anything. This dl by l is fine. If you see this tan theta graph, you can easily get this value. I am not going deep into this derivation, it is quite simple and follow. These are the main things with the sign bar. So in the question it might be, they they will give the size of the, they will mention what is the sign bar length, then they might give you the this slip gauges height, and they will directly ask you will ask you this theta value. So it's a straightforward question. You just have to remember how to use this length of the sign bar in the formula.
Sir, in the expression of d theta equal to tan theta, that is dh or dl?
Yeah, just a second. This is dl. Okay, the error with the length, it will it is always, it's constant, dl by l.
Okay, sir.
Okay, then it will be like d theta is perpendicular to tan theta. That curve will be like this. This is where the 45 we got. Okay, this in this range we will play only within this range. Okay. Then you should also remember they might also play with this this roll diameter also. Sometimes they might give this roll diameter, so that you should not get confused with that. Okay, so it will a simple basic formula you can use, whether to subtract this diameter or radius while doing that the certain question. You just apply basic common sense that you can easily figure it out. So that is all about sign bar. There are a couple of questions in the sign bar, you can easily finish it out. Then this angle gauge is also similar to what we used the slip gauges. These are also having some standard sets. So basically so it is a flat but tapered. So this is the theta that we use. As we have a slip gauges with standard height, we also have standard this angle gauges with standard theta values. Say for example this is 5 degrees thing, and we keep these things on the flat. This flat surface will be with the any surface that you want to measure. Suppose I have an inclination like this. So what I do, I'll put a gauge in this, and I will measure this flatness. This should be flat, so that I will come to know this inclination. Okay, accordingly I can find the value of this theta. Okay, so this is this angle gauges. So I will give the range also for this. Just a second. So before that let me ask, you know this degrees, minutes, seconds. So just tell me 1 degree is equal to 60 seconds, 60 minutes, and how many seconds?
100 seconds.
Okay,
60,
okay. Miss 1 degree. I am asking for 1 degree.
3600.
Yeah. So it is 360 degrees. So if any value is given, you have to divide or multiply with this value in order to get how many seconds it is before using in the question. Okay. This is a small mistake generally people do. Let me give one example. Suppose if I say theta is equal to 32 degrees, 5 minutes, 6 seconds. Okay, and I have a this length of the sign bar as 200 mm. Can you give me the height? Sorry.
Sir, is it 360 or 3600?
This one, this 360.
Okay.
Sir, 360 कैसे?
Yes, yes. 1 degree is equal to 360 seconds.
So 1 minute equal to only 6 seconds.
6 seconds.
Me-
Yes.
1 degree equal to
Yes,
6 seconds होगा फिर sir.
yes, yes, yes.
Hundred and 6.28.
Yes, sir.
Okay.
28, sir.
I'm getting 109.17. Hello, sir.
How much you are getting?
109.7.
109.7. Okay.
Sir, I confirm that 1 degree equal to 3600 seconds, sir.
1 minute is equal to how much?
1 degree equal to 3600
36. Yeah,
seconds.
yeah, yeah. Sorry. This is 1 minute is equal to 60 seconds, right?
Yes, sir.
Yeah.
So, sir, the H value is 106.2356.
Correct, correct. Yeah.
536.
Sorry for the confusion. So we have 60 minutes, and correct.
Yes, sir.
So then we are getting 106.235 exactly.
10.
6.235.
Yeah. Yeah. So how we are getting 109.7?
So I have took 1 degree is equal to 6 seconds.
6 seconds.
That initial configuration
Okay.
that you
Okay.
have.
Is this correct?
Yes, sir.
Okay. Thanks.
106.23.
Yeah. Okay. Let's move to the next topic. So this autocollimator. So these the whatever we discussed in interferometry. So most of the questions are like memory based questions. So can anyone tell why we use this autocollimator before going to how it works, the principle?
Flatness.
Nice. Flatness.
To measure the small angular displacement.
Okay.
So using light.
No, no. Why we are using autocollimator? So why I cannot say why. So what are the parameters that you measure using this autocollimator? What the
Small
purpose?
angle.
So very small angles.
Okay. Small angles. True. Flatness. Can I measure flatness and straightness?
Yes, sir.
Yeah. So these are the two or three: flatness or straightness, then angular, small angular measurements. So so the principle is very similar. So we will have a small stylus kind of, it is little rollers on an uneven surface. We will have a light source. So if there is any disturbance in this, if I'm doing in one direction, it is a straightness. If I'm doing in 2-3 directions, I can get the flatness of the surface. So if there is any tilt in this stylus that I'm using, I will have a this tilt here itself. So this is the tilt. So what the image, the light source image, it will have a deviation. So I will get this image in some other place. I will have this d, this theta. So the relation is, so I can use d here. Okay, this is the basic principle that I use. You mainly have to remember these things, why we are using autocollimator, and this is the principle we use. Okay, this
So
reflection.
F is
Sorry,
focal.
focal length. Yeah, yeah. This is focal length. This is the tilt, and this is the distance at which the image is formed. Means the image will shift by some distance due to this deviation in the tilt.
Sir, where is the source of light placed?
This is the source.
So D is the distance of.
Distance from the initial point, that is the source, to the image that formed due to this tilt. Okay, I will have a scale here, so I can measure this distance easily. Actually, I will have a eyepiece also here. I have given very simple diagram. So if you find autocollimator, you will get there is a very complex thing actually involved, but this is the simple way you can remember. For measuring this distance, I will have a eyepiece somewhere around. Like I can use a, so there is if you see that principle, it is easier. I have to use a prism. Then to that prism, I will have an eyepiece here, so that when the light is going, I will also get this the let me, so I will have an eye here. So the deflection which is going, that you are seeing here, I will also see in the eyepiece the distance, that distortion, and I will also have this crosshairs. These are the crosshairs I use in to measure this distance. You don't have to go in that much depth. Just have to remember this thing and a simple working principle. Okay.
Okay, sir.
Yeah, just let us move to so let us spend some good amount of time in the important topics. So this is one more important after limit gauges, after this angular measurements. This taper or internal diameter measurements are one of the nice concepts. So before going to this, you should know some as I discussed earlier. I think you have already seen once. So small little amount of basic geometrical understanding you should have. So let us start with this angular bisector. So can anyone explain what is this angular bisector?
Line which divides the angle into two equal angles.
Yeah, yeah, exactly. So this is the main concept that is involved in this taper angle measurements. Suppose if I have a circle here and I am keeping the one more circle but with the center on the same line, and one more center in the center of the same line. Suppose if I draw a tangent and one more tangent here also, do you think this theta will be same and this angle will be 90 degrees? Any objections? Since this is a tangent on the surface, it will form exactly 90 degrees.
Yes, sir.
Okay, if I join it to the center here. So where is the angular bisector here?
The
Center
line
line.
joining the center of circle.
This one, right? Yeah. So this is the angular bisector in this scenario. So this 90 degrees, this angular bisector, these are the things you should keep in mind. So you should if you are expecting any question from this thing, it will be very new every time. So let us start with a simple case, then we'll move to the complex thing. I will give one small example for you to work out. So let us start with simple thing. Suppose I have an object with one side inclination. So before that, we can use directly sine bar or angle gauges in these measurements, but it is complex to you take these things everywhere, and it is sometimes it will be impossible to take these angular gauges or sine gauges. In that scenario, we already have standard these balls. Okay, so directly we will use, with the help of these standard size balls, we can directly measure, and the dial gauges that we have, we can measure the heights as well as the contact points by doing some by applying some this trigonometric equations. We can directly find this angle at the taper angle, you can see. Now as you can see, there is angle here theta. Suppose in this case I use two balls. So this is one and one more. Okay, and I also have the values of these heights. It's very small, this h2, I can say. This is the datum, this is h1, and this is very small h2, and then I have the sizes of these two. So I'm indicating this is O1 and this is O2. Similarly, you will have R1, R2. Diameters are the radiuses. Okay. So now, can you give me this theta?
These bonds are coincident, are they one to one?
No, they are not coincident, because the other surface is it's half tapered, so they are not coincident. That's why some deviation I have shown here. They are not coincident.
No, sir, actually the bond is one over the other length between the answer.
I'm sorry.
The second bond should be, I think, on the first bond.
No, so in this scenario, the ball centers are not coinciding. Correct me if I'm wrong.
The balls make the point contact only, sir.
Yes, yes. You can treat them as a tangents. These are like the tangents.
Sir, H2 is the distance between.
This is very small difference. You can, so let me increase this. So this is the H2 value. Okay, and this is the H1. Okay.
Okay, sir.
So the second ball is on front or in the back? So
This one.
the second ball,
Hmm.
which means it is on.
So initially I kept ball 1, I measured the H1, then I kept the ball 2 on the ball 1, then I measured H2.
Okay.
Okay. Hmm. Yeah.
Sir, it is giving, is it tan theta is equal to
Yeah, you give me
something?
whatever expression you are getting, you can give me. Then I
I
will
have
see.
a tan theta is equal to
Yeah.
R2 minus R1
Hmm. Next.
upon upon R1 plus H1
Okay.
bracket comes minus R2 plus H2.
Okay. Nice. So initially you can find this O1 O2 distance. Give me the expression for that. This one I'm talking about this O1 O2 distance. It's not R1 plus R2.
So is it R2 minus R1? Okay.
Yeah, this is R2 minus R1. Sorry.
No, sir. Over.
O1 O2.
Yes, sir.
No.
If we are taking angle between O and theta, which is like.
No. No. Just check. I will write an expression initially. Just check it. So H1 plus R1 minus H2 plus R2. Just check whether it is correct or not. 1 or 2.
Sir, this expression divided by cos theta by 2, then it is correct.
Okay. Any other?
Sir, how does that expression tan theta equal to R2 minus R1 arrive upon?
Yeah, I will discuss.
Sir, O1, O2 is not vertical.
I think they are not vertical, they are lying on this line. Okay, let us try. So this H1 plus R1 will be this height, right? The vertical height. That is H1 plus R1. That will be this distance. Right here itself. This is R1, H1 plus R1, the total distance. Then minus H2 plus R2. That is. Suppose if I am taking here, this will be H2 plus R2. So this is the, if I subtract these two, suppose this is the height, that is you can see that is the vertical height I am getting, O1 O2, and I have a this line, and this is the distance I need in order to get this theta value. This is O2, this is O1. Say I have this value, that is this. Let us give an initial A. Then so I have a tangent here. I should try a little bit tilted. So this is the tangent. So I have this difference. So this is the theta I need actually, and I have this value, that is R1 R2. Sorry, R2 minus R1. So if I can find this in order to get this tan theta, I need this opposite side. Okay, so let us try. So this is 90 degrees. So what would be this angle? Can anyone tell me? means I don't sorry, I don't need this data at all, I think. Yeah, just I will simplify this. I think the location is itself different. So let us proceed with the available data, then we can easily get this. So since we have this vertical height, say some a b, that vertical height is h1 plus r1 minus h2 plus r2. So we already have this vertical height, and this will be the theta. Okay. So what would be this opposite side? Is it r2 minus
R2
r1?
minus.
Yeah. So if you are confused, just draw a straight line here and here. It should touch the center line, so that the distance will be r2 minus r1. Okay. Then if you apply this tan theta, I think you will end up with this equation.
So this angle is theta or theta by 2?
And depends. I can take theta is directly, because it is not exactly dividing, so it is theta.
Sir, which means like we cannot guess the type of question which will be
No, we cannot guess. So this is, I think I should have taken this a bit later. I should have taken the simplest one first. So let us discuss that part first. Let us solve one question. I think it is already. So similar concept. This is, I think, even simpler compared to the earlier one. So in this case, I have a taper on both sides. So you can take the help of this angular bisector. So initially I kept so these are balls I kept one by one. Now the centers coincide, okay, and I have the values of the rest. Sorry. Okay, this is H2. This will be H1. So just give me the value of so in this case just give me the value of theta. Just first give me the value of theta by 2 instead of theta. So I have O1, O2, the rest are same. So you can take R1 or D1. This is R2 or T2, the radius and diameter. You can use any one, and you can just give me the value of theta by 2. So I give 2 minutes, then I will discuss.
So here it will be cos theta by 2 equal to R2 minus R1, R2 minus R1 upon H1 plus R1 minus H2 plus R2.
Just wait for a minute. Let us see. I think something wrong with this cos or sine.
Sin theta way to getting. I'm getting sin theta
Yeah,
way.
yeah, correct.
हाँ सर 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 साइन थीटा हो गया.
Okay, nice. Okay, if you understand this one, I think rest will be similar. So, any doubts?
No sir.
Thanks. So let us. So I will give a small like homework problem. We just try to.
Basically, can you show that solution?
Okay. Yeah. Here it is.
Yes.
Okay. So just think. Suppose if I don't have H2 and H1, instead they have given me these values. So the distance between this and the center line distance. So instead of the vertical heights, I have now I have this horizontal dimensions x axis and w. So this is one you can try out. Similar you can use of this triangles formula, this angular bisector, and you can find in that case. So only one thing will change. You can try, and this is one problem for homework. Then I am giving some other one. So I have a keyway. So this is a keyway. So now I have this as D. So this is the roller. Okay, and so now I have the values. This is L2 and same length between the smaller one is L1. Then this is R1, this is R2, and then similarly this side also you can take R1, R2. Same rollers I am giving. Just give me the dimension of D. What is D here? Okay. Just you can note it down and take a screenshot, and you can try to solve this. I think it is straightforward. Then we will discuss some of the concepts. So this is a theoretical question. Clinometer are angular decor. So if you have any civil friends, so there is one term. So there is one device called theodolite. So basically they will have this standard chain length. Suppose I have a big building. If I want to measure the height of this building, So basically they will have a standard size of chains. So with that they will get this distance easily, this length L. So if they can, and by any means, if they can get this theta, they can easily measure this height. So for that we will have a so in civil terms they call theodolite. In our terms we will call clinometer or angle decker. So it's simply a telescope. So it's a small type telescope with a angular measuring setup. So when it is horizontal it will be 0 degrees. When it is tilted you can get this tilt. So that tilt is exactly equal to this theta, and you have this L. If you apply simply this formula, you will get easily this height. Sorry, cos theta. Okay.
तो tan theta सही तो था.
Okay. I think initially I wrote correct only. Sorry, tan theta it is. Okay.
What was the question?
Sorry.
What was that chain?
Chain length. So they, for surveying they will have this chain length just to measure this distance.
It will be standard length, sir.
Yes. I think like some 5 meters length. They will have. It is easier. They can use a tape also. Okay. So that is these small concepts. So till now I think there is no question on these small devices. There is one question in this autocollimator, just asking the purpose of using it, and you can spend a little more time on these things to measure the taper, internal taper. And there is one more question I think. I'll just you can just sort it off. So there is no hard way to learn this. There is no formula in how to get. You have to apply these basic principles and get. So there was a question, you might have already seen this. Let me try quickly. Have you seen this question earlier? So there will be a ball like this, and there will be one more ball like this. You might have worrying how this entered. Let me increase this size. So this is the. So I have drawn a rough diagram. So they will give everything with for you. So this length, everything they. Sorry, this length you have to find D. The rest they will give. Like this diameter, this diameter, and the heights. I think I have to further reduce this, and this height, h1 h2 d1 d2. Okay, and they are asking you to find this width d. Okay, this is one gate question they have asked. So similarly they can ask any type of geometry. So there is no hard way to learn. Okay, and this is quite simple. If you have any if the centers are coinciding, you can, I think this is the plan you have to follow. Something it will come like r2 minus r1 upon this h1 plus r1 minus h2 r2, and you have to observe this theta by 2 also. Because in question in hurry you might directly write this theta by 2 value. They might ask you this half cone angle or full cone angle, so you have to pay attention in those things, these small things, otherwise it will be completely waste of time. Okay, so it's already 8:22. I think there is small pattern screw thread measurements. So before that, so in these screw thread measurements there is one the popular question. So can you guys tell me what is best size wire?
P by 2, 6.
P by 2 into
No. What is the definition?
The size of the wire that will be in contact with the pitch circle diameter.
Okay.
Sir, are you talking about three wire test? Like,
No. Best wire size. Yeah, that is the correct explanation. So suppose this is the suppose I have a screw. Okay. So I am just magnifying this part. This is the peak and this is the value you have. Okay. So if I can place any type of diameters, so I have some any two wire two wire method or three wire method. I have wire any two wire method or three wire method. So suppose if I have a big circle like this, so it might contact somewhere else. If I have smaller one, it might contact somewhere. So there will be one size which will exactly contact with the this pitch circle points. So that is the best wire size. Let me remove the others. Okay. So one is which is exactly in contact with this. Okay, this is the D. Suppose this is P by 2, this P by 4. Okay. This is theta. So can you give me this best wire size?
P by 2 secant equal.
Is it correct?
Second, can you mention about P by 4, P by 4? How is it?
P by
P by 2, P by 4.
P by 2 secant theta. Okay. So you are asking can you
sir, the center of the wire should be above the pitch circle, sir.
No, in this case I am just keeping on the center. Just give me the value of D. So this center is exactly coinciding.
So which is P here?
So, sir, the center should be or the contact point should be with the pitch line.
Suppose if I have both on the same line, think like that. So what you are saying is exactly correct. So it may happen.
सर मैं पूछ रहा था, मैं बोल नहीं रहा था मतलब.
अच्छा okay fine. This is also fine. This is the origin.
Center can be above the circle line,
Yes.
but it should just touch it.
Yes, these points, these contact points wherever I'm keeping, it should touch the pitch circle. So this is the pitch circle line, right? So it is exactly touching there. Sometimes it might touch below or above also, right? So but for best wire size, you can blindly keep in mind that it is touching this pitch circle line, pitch circle point, so that this distance is exactly P by 4. If it is above or below, it is not the same.
So P by 2 is half the complete length also.
Half P by 2 is half. This is P by 2 and this is P by 4.
Yes.
Yeah, this is P by 4. So is this correct? Just one more. This is correct if you can easily get.
So D is the diameter.
Sorry. Radius. a triangle here with angle
Sir,
theta here. Yeah,
sir,
yeah.
what is this theta? Is this pressure angle or?
It is I can say half thread angle. Thread angle. This is,
Oh,
yeah. Theta is the thread angle.
Thread
Generally, it
angle
will be
or
2
thread
theta.
angle?
Sorry.
Sir, theta is thread angle or half the thread angle?
I think it is just a second. The angle. So this is it depends. So it's half thread angle actually. 2 theta is the complete thread angle. So the definition is the angle present between flanks, which are these. These are the flanks. So the angle present between. So this total is the thread angle. So theta is half thread angle, you can say.
Yes.
Here our concentration is fully on this D, best by size. So we have this P by 4 and we have this R. That is okay. Yeah, this is one important question. I think you already know different types of the nomenclature in this screw thread. So the major diameter, minor diameter, pitch. Can you give me quick like definition of this pitch that we use in screw threads? What is pitch? So that
When
we are having
two
this. Yeah.
when like when two screws are in contact, that the point of contact, that is the pitch.
Okay. Can you give me a simplest way of understanding pitch? Uh, that is true.
The distance between the two successive points on the screws.
Even more, you can simplify. Two
one
successive points. That
revolution,
is correct.
one revolution rotate करने पर उसी.
What is lead then? Lead. That is true, but this lead is what exactly suits that definition. So for pitch, you can simply. So we have already seen there are peaks. We have already valleys. We have peaks here. We have valleys here.
The distance between the two peaks.
Two successive. That you should
Two
two
successive.
consecutive or two successive peaks or valleys is the pitch. So you can take the reference of these things. So that is the main confusing thing, this pitch. And you should also keep in mind how half pitch or this quarter pitch P by 4. So they might directly ask you, they can use this thread angle and pitch, and they might directly ask you this what is the best by size dimension, or they can reverse it. They can play with this formula basically. So this is fine. And what are the devices that we can use for measuring these types? So for major diameter, that is from this peak to peak, that is the major diameter. The maximum size of a screw is the major diameter. So for this we should use one standard instrument. Anyone remember what instrument we use for measuring this major diameter?
Micrometer.
It should be specific. Micrometer is general, but for this we use very specific micrometer.
Screw thread micrometer, sir.
Okay. So it's a micrometer, but it has a prefix. So that is flat-ended micrometer. So thus it will be like this. So that it exactly makes contact with these peaks. Okay. Similarly, we have one more thing to measure the minor diameter, that is this diameter, the smallest diameter in a screw.
Peak ended micrometer.
Yeah, correct. It's pointed and will micrometer. Okay, these are the main instruments. So they might ask you this theoretical. So I just mentioned those. Then so these are fine for measuring the maximum size. So for internal measurement, suppose if I have a internal screw thread, so what would be the best way to measure? Because in this I can easily measure, it is open screw, I can easily put this flat or pointed anvil, but in case of internal threads, how to measure these things like pitch
Can we use vernier caliper?
okay, but suppose if I have say some 2 mm or 3 mm inside thread, the maximum diameter, so but these vernier calipers are various standard sizes, so it will be difficult for me.
Sir, I'm not getting this part where you told like P by 4 secant theta, P by 2 secant theta.
Can you speak a bit louder? It's not clear.
So is it clear now?
Yeah, yeah.
Sir, actually this P by 2 secant theta, P by 4 secant theta, sir.
Yeah, you figure out how.
P by 2.
Okay, here, yeah, yeah, sorry. It's P by 2, sorry. Okay, where we are. Yeah, for internal measurements, so there is process. So in which, suppose if I have a internal features, so I just pour some wax inside, fill the cavity completely, then unscrew the wax and measure the things. It is like measuring the outer screw only. So that is the process we use. So there are no special instruments for that. Okay, we just put some wax, solidify it, take it out and measure the things. So these are the main concepts involved. Then we also have this measurement of so we have some types of measurements, 2-wire method or 3-wire method. So we instead of using these balls, we in the screw threads we use these wires directly and we can measure the dimensions. So this is also something to do with the similar thing that I discussed in the taper measurements. Okay, so so there is limited time, so I cannot discuss that thing. So in the next class I will discuss, I will start with, if possible I will start with this screw thread measurements. So there is only one part pending, that is measurement of effective diameter using this 2-wire or 3-wire methods. Then some concepts on the surface finish. I think with that we can wind up this metrology. I think you guys know this telesurf, right? Working principle of telesurf. Okay, I will discuss that also in the next class. And this surface measurements is a little important topic, so I will spend some good amount of time on that rather than spending more on this thread measurements, screw thread measurements. Yeah, any doubts?
Sir,
If
in
you have
case,
time, you can.
Sorry, one by one.
Sir, if you have time, you can extend up to 9 also.
Okay. It's fine, it's fine. I can discuss in the next class. I can take some 2 hours lecture if possible in the next class and finish up everything. So we are only pending with this surface measurements. Then I will talk a little bit about this non-conventional machining process. I think there is one more class on the same topic, but in that they teach this EDM and ECM process, which are very important. And this UCM, the other topics are like they are morely theoretical based, memory based questions. So I will discuss little bit on those. Then we can wind up the sessions.
Sir, regarding the screw thread measurement, we have only the best wire.
Yes. In this is the main topic. Then this nomenclature is one topic in this screw thread measurement. Then finding this pitch circle diameter is one topic, which is straightforward. Okay, like you have seen in thread angle measurements, it is more or less similar.
Yes, sir. Sir, actually, if we have the wire diameter such that it will exact the center will exactly coincide with this pitch circle,
Okay, yeah,
then D will be equal to P by 2. So, like
correct,
then we will not be able to measure the angle.
correct, yeah, exactly. Okay, if there are no questions, you can leave the sessions and carry on with your work. Yeah, thanks for attending. If there are
Hello,
any
sir.
doubts, I can stay. Yeah.
Uh, what point you were telling that they can play with this pitch? So, can you repeat that point?
Okay, this thing.
Yes, sir.
So I'm just asking how. I'm just saying how the questions they might ask. So initially they can directly ask you, give this pitch value and the theta thread angle. Then they might ask you this best wire size. Yeah, or they will give the best wire size and they can ask you this pitch value. Okay, so this is something to remember about the best wire size. So if you don't know about best wire size, it is difficult. You should remember that's it. Nothing about this. This is a simple concept.
So, can we have a small brief discussion, if possible, about this nomenclature and pitch circle? So, if possible, in the next class at least.
Yeah, sure. I think I covered most of the these nomenclatures. Then yeah, I can revise once before starting the lecture.
So, suppose if they are not directly giving the pitch size, so like we need to indirectly calculate such thing.
Yeah, correct. Yeah, they can use in that way also. Yeah. Or else they can directly ask you what is pitch circle and they might give some options. Okay, I will revise a bit on the nomenclature, then I will carry forward.
Okay, sir. Thank you. Sir.
Okay, yeah, thanks.
And are we going to learn about two-wire, three-wire methods in next class?
Two wire and yeah, two wire and three wire are more the derivation part is similar. Okay, the basic difference why we go for three wire is if the size is too much. Suppose the screw thread that measurements the scale itself is bigger, then we go for three wire. If it is smaller scale, then we use this two wire method only. But the derivation part, everything is similar. So I will discuss about the two wire method in the next class. These are all to measure this pitch circle diameter or the effective diameter. Okay.
And what was that point you told? Someone told that when D becomes equal to P by 2.
So in that case, you don't have to measure. So you already directly got the that pitch value.
But in that case, wire is touching below the pitch circle.
No. The question is, suppose this D is exactly lying on this pitch circle line. If at all possible, so in that case, we don't need this pitch value, or we don't need any of the values, the wire value or the pitch value. We can directly get the theta value, right?
Yes.
Yeah. Okay. Any other doubts? So, do you want me to discuss any other topic in the next class instead of this unconventional machining process? No. Okay. Yeah. I will see you in the next class then. Yeah. Thanks.
Okay. Thank you. Thank you, sir.
Thank you, sir.